All right, so we're all going to take a look at this and we're going to see where we are. Just let go of one. 4-6. Now, ladies and gentlemen, my advice whenever you're dealing with two triangles that are overlapping is to separate them. Okay? Turn them into two separate triangles. So this one here, we're going to redraw it. Thank you. All right. So all I did was separate the two pictures. And you want to make sure that if there are named any named points, that you're labeling them properly. Okay. So the process of doing these proofs. First, mark all of the tick marks. Use the given statements. Okay. Do the givens first. So they told me that I have two right angles, and they're marked. They also told me this. WZ is the same thing, is congruent to VX. Okay, mark the picture, draw on the picture. Now, what else can we mark up? It's not vertical. We don't have a Y. Oh, well, yeah, this Y, actually, this Y doesn't matter anything to me because what I'm really trying to find is WVZ and VWX. I don't need Y. Y is just extra, in a sense. It's not part of the triangles I want.
Is it that that line BZ is congruent to line WX?
Well, if we want to, you could put a mark here, but I don't know if it's true. How do you know it's true?
Because we don't have the right component.
But does that mean that they're the same length? What do I know is the same in both triangles? B? VW. How do I know that VW is congruent to VW? Their shared side. What property allows me to do that? What do you call that property? The reflexive property. Okay? It's shared between both triangles. That's reflexive. All right. So, we have to fill in. We look here, and that gives us a hint what needs to go in that place. So what should I put on line 1? Steve, what should I put on line 1? Line 1, right here. There's a hint.
Angle WPC and VWX
They're right angles. little small. What else can I put in there? What's my next line going to be? Okay, so all we're doing is just rewriting the given statements. All right, what about line 3? Supposed to be doing reflexive property. So what goes in there with the reflexive property? Let's get some of my not so frequent flyers. Okay. Is it now? VW is one of them. What about, should it be VW or WV? WV, because if you're going from right angle to acute angle, you want to be going from right angle to acute angle, so it'll reverse order. All right, and now finally I can wrap this up using the HL theorem and what goes down on the last line. But now, what's on the last line of a proof? It's what you're always trying to prove. Say it. Thank you. Remember, that's what you were asked to prove. That was the goal. So that's going to be your last line. And how do I know that it's true? From the HL theorem. Okay. Hypotenuse leg is when you have angle side side. You can see I have angle side side, angle side side, angle side side. But it's a right angle, and that's the one time that it works, and that's HL. Okay? All right. Questions on this one? There's one line that I think should be included in here, but it wasn't. And that's when you say that these two right angles are congruent to each other, because all right angles are congruent. That should be included in the proof. But whoever wrote this worksheet didn't feel the need, but I do. All right, so we're going to be, questions 2, 3, and 4 use the same picture, so I just took the picture out for this slide. All right, if x is 54, what is angle z? Because it corresponds to, yes, this is measure of angle z equals 54 degrees. So now if x is 54, now notice how they wrote this, 3 letters, V, W, Z. V to W to Z. What would that be right there? It's a little hard to tell, so let's separate the pictures. It's always a good idea. Separate the pictures and look at them piece at a time, one at a time. So let's see if we can try and figure this thing out. Where are we going to put it? ultimately need to find the question mark. That's the job at the end of the day. You sure? Yeah. How do you know?
I don't know. He the square is 90 degrees, so it's 4 plus 90.
Right. So we have 90 plus 54 plus angle VWZ equals how much? 180.
Well, yeah.
So now this is 144 plus angle VWZ is 180. VWZ equals 36. Okay, some of the angles of a triangle is 180 degrees. So we use that to find the missing pieces. All right, let's. You okay? You okay? So can we prove these two triangles are congruent without the HL theorem?
Yes. Yeah.
I'm not so sure. You'd have to do some pretty fancy dancing in order to do it, but it might be possible. The only way that I could imagine doing it is saying that because both of these lines are perpendicular to the same line, then they're parallel, which means that this and that are alternate interior angles. And the same thing goes with here to there. And you can begin building another proof, but it would not be a pretty one. Certainly not straightforward. Yeah, yeah, that one's a little bit out on off the charts there. But let's keep going. All right. This kind of a problem is important. This kind of a thing will pop up on the next test. Please pay attention to these kinds of problems. All right. For what values of x and y are the triangles congruent by HL? All right. If the triangles are congruent, if we want them to be congruent, you okay? Sure? Okay. If we want them to be congruent, then their lengths have to be the same. The corresponding lengths and the corresponding angles would all have to be the same. Okay? So we want to be able to figure out a way to go around this thing and see what's happening here. All right? So, Thank you. Who's this? Oh, he is currently not with us right now. I'm sure he would have liked to have known it, though. Thank you. Okay, these are tricky, okay? But let's see, what would x equal? What would this x equal? What does the x correspond to? 2y. Because those are the two hypotenuse. Okay? And what would x minus 4 equal? y plus 3. Okay. We have two equations and two unknowns. My advice is to use substitution. Since you know what x equals, plug it in. And solve for y. Since you know that x equals 2y, you can replace x with 2y.
Oh.
Erica, are you all right over there? You okay? Okay. Let's try this problem now. Thanks. Well, if that's what you think, keep it to yourself until you've found x, and then we'll see what happens. Let others have a chance to find it on their own. I think you might have lost a line there. What do we get? Algebra? Right. So what is x equal? 14. X equals 14. So plugging back in. So x is 14 and y equals 7. All right, using that same idea, let's see if we can set up and solve this one. What do we have? Y plus 5. What does y plus 5 equal? And down below, y plus x equals try and see if you can solve this system. Who's got my y? What's y equal to? Come on, you guys. You can get y in one step. Yeah. Come on, guys. What is y?
Y just from this equation. Can you find y just from this equation?
No, it's not. Go ahead. Yeah. What am I going to do to get that to do that right there? Second equation. One step. You get y. What is it? Yeah. Just subtract x from both sides, guys. This isn't, you know. Yeah. Right. minus x minus x. Yeah. Come on now. Whew. Right. Yeah. So now you can plug in and find x. Yeah. What'd you get? Come on, plug in 7. Come on, solve for x. We need to talk to our algebra teachers. Have a little conversation. What do you got? 2. Thank you very much. Whew. Wow, that was like pulling teeth. I can just do this straightforward. Well, it looks like we might need to practice that a little bit more. What do you say? Okay.
You have put something without out.
Yeah. Got to be able to do the basic algebra. All right. I'm not about to ruin a perfectly good mood by doing number 7, so we're going to skip to number 8. All right, ladies and gentlemen, this is a very important problem that I'm really glad we got an opportunity to look at. This one, I know what's going to happen. People are not going to read the instructions when they get to this question on the test, and consequently, I'm going to get all sorts of really bad answers. Read the instructions to yourself for a minute. All right. So I'm being asked to prove these by hypotenuse leg. I don't have enough information right now, but I want to. I need something else. If you could give me a tick mark, I could do it. Right? Erica, stop with the conversation. I want you both paying attention to this. Yes, question. Right, they are. But it's the one exception to angle side side when you have a right angle. When you have an angle side, if you have an angle side side with a right angle, then it's hypotenuse leg. It's the one time.
One of the problems was correct, but the answer was just hypothesis leg.
Yeah. Yeah, if they put down angle side side when it's supposed to be HL, that's wrong.
Although it was not hypothesis leg, it was the right angle side.
Okay. All right. So what are the 3 things we need for hypotenuse leg? I need 3 things. I need a right angle. Oops, excuse me. I need a right angle. And what else do I need? A right angle, but what else? I have to have a side. I have to have one leg. And as the name says, what else do I need? HL, right? What does HL stand for? I need a hypotenuse. Remember, the hypotenuse is the one across from the right angle. So let's look at number 8. I have a right angle. Is BC a leg or a hypotenuse? Who votes it's a leg? Who votes it's a hypotenuse? Who doesn't know what a hypotenuse is? Who doesn't care what a hypotenuse is? Okay. This is the hypotenuse. It's across from the 90. Either of these are the legs, okay? The smaller pieces. So, what do I need? I need a tick mark on something. What should it be? What is it? Okay, so I need what to be congruent to what? Nice. I need AC congruent to DF. That's what my missing information, additional information is. What missing piece would make it right? Look at 9. I'm missing something. I need that. So what am I going to say? What is, what? Yeah. Which one? Number 9. It's okay. Jason, what am I going to? I need hypotenuse leg. I don't have enough. I need something else. What do I need? Give me how do I write that? Something, something, congruent, something, something. What am I going to do?
Angle A and L is congruent to CSI.
We need this and this, right? So we could just say angle M is congruent to angle S. We could give a 3-letter name if we wanted a 3-letter name, and that's enough. NML, TSR, that would be fine. But since these weren't touching and there was no question about what is angle M and what is angle S, I can use a single letter. What about 10? Okay, so Edwin, hi. How you doing? Good. What should be congruent in order to be hypotenuse leg? Give me something. Okay. LK congruent to who? Yes. Very good. Nice. Very nice. What else? If you didn't do that, is there another answer? Because this is correct, but there might be another answer. So instead of doing this one, which is what you did, which is correct, there's another one we could do that's also correct. What else? JL, I heard somebody say? Would be congruent to who? MO. One or the other. Either one would be fine. Okay? Last one, number 11. What can we immediately mark? Juan, what can we immediately mark? For free. Yeah, XZ. How do you know that? What's that property called? Reflexive property. Very good. Okay, so we have a hypotenuse, we have a right angle, I need a leg. Somebody give me a leg. Not a wing or a thigh, I need a leg. What? Okay, WX is congruent to who? YZ. Is that the only one I could use? What would be the other one I could use? XY? Congruent to ZW. So either one would be fine. One or the other is fine. Whoa. Don't do that. Don't do that. Let's avoid that, shall we? All right, good. All right, now for the fun one. Now, ladies and gentlemen, I'm going to tell you right now that last year, when we gave this test to those students, the coordinate geometry proof that they had to do was muy malo. It was really not a lot of fun. So, we're going to make sure that you know this one down cold. The SOL loves this problem. Ones like it. So, distance formula is a big deal. Okay? If you can do the distance formula, you're going to be pretty well off. All right? Also, the slopes, having negative reciprocals for right angles, stuff like that, that's important. Right, guys? Right? Right. S. Okay. So we are trying to show that AC and CD are perpendicular. That's the job. The slope of AC. What's the slope of AC? You have it. You can look at it on your paper if you can't see it up here. What's my slope? Slope. What's the slope? Positive or negative? You don't even need to. Just look at it and count it. It's a negative 8 over 4. Just count it. Or you can even see that slope is the same here. So down 2 over 1. Or you could go all the way down. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Down 4 over 8. Either one. Guys, if you can't do slope, you're toast. Okay, you got to be able to do slope. You've been doing it for, heck, since springtime of 2015. 2014, what am I talking about? You've been doing it for a while. Pre-algebra. And the slope of CD, what is it? 1/2. The product of the two slopes. What happens when you multiply those two slopes together? What's negative 2 times 1/2? Okay. Whew. I was about to. A small little voice deep in my soul began to cry. Saved by the bell. We will pause for a commercial break. Please come back with your brains intact.